So today we learned a lot about QObjects and all the core classes. So in the second part we will concentrate on the UI part of your applications. So what does it mean to create your own widgets? How can you develop your own UIs? So we first concentrate on the widgets, and then we try to create some application and use Qt Designer to create our own UIs to make fancy user interfaces. So when we talk about widgets, first of all, we can use some common widgets which are already within Qt. So we don't want to reinvent the wheel. We will use what we can get from Qt. Then again, we have to talk about layout management and some guidelines for our custom widgets. So if we talk about common widgets, we will have a toolbox of predefined widgets which we can use, and I will show you what you can use from the Qt framework. Then talking about layout management is of course the geometry management, the positioning and resizing of your components. So let's have a look at some predefined text widgets. So we already know about the QLabel, which is just a simple text element, but it can also represent a pixmap. So a label can look like this, text with a frame or just a simple text, or we can use a label to show a pixmap. A line edit is an input field for a text which can look like this here. We have a single line edit for entering text, or for some specific purposes we can enter a password and we can tell the line edit to set the echo mode so that the user cannot see the text he types in. And text edit, QText edit is mainly used if you have larger text or if you would like to show some HTML text. Using different font or colors, you can use QText edit for that. There are some button widgets available within Qt. Everything is derived from QAbstract button, giving you the base class functionality. And then we have some specific push buttons, radio buttons, checkboxes, and we can group everything together. So the push button can look like this. It can also be shown as a toggle button, so it keeps pressed once you press it and it gets out once you press it again, just by setting the checkable property to true. Then you have a toggle button. Everybody knows radio buttons. It will look like this, so that you can just select one button of a group of radio buttons. Yeah, checkbox is a text label with a check mark. And you can use all these buttons in a button group where you can say this group is a group of abstract buttons, and if you set the exclusive flag, you will have the behavior of a radio button so that only one of these buttons can be checked at a time. So then we have some predefined widgets for values like a slider or a progress bar or a spin box, which nearly have the same API function. So we can set a range with a minimum and a maximum value, and we can set a current value. So all this applies to all of the three widgets. And whenever the user changes the value, we will be notified by a value changed signal. So then there is some additional widgets available to organize our UIs, a group box, which looks like a frame and a caption, so where you can group specific elements. Or you can use a tab widget just to show some tabs where you can switch different pages. Of course, everybody knows what a combo box is. In Qt, it's Q combo box. And we can add different items to the combo box. We can also supply some additional data to each item within our combo box. So let's say if you just show some text information, you can set some additional data in the background that you know when the user clicks on this item, which object it is actually. All this can be stored in the item data. So this item data is also very useful in list widgets. So here we see a list widget containing different items. And for instance, we set the checked state of the second item to true, so a checkbox appears within our list. And then we can attach some data to it. We can say the second item has some additional data. So we can pack everything in a variant and set a data for a specific row to this item. Yeah, even more widgets like toolbox, date and time edits, calendar widgets, tool buttons, splitters, stacked widgets. And this is also a good point to introduce the Qt designer here. So let's just open our Qt creator again. So whenever we design some user interfaces, then you see a toolbox on the left side showing you all the available widgets. In this toolbox here. So everything I just showed to you is available on the left side. So let's say a group box. Put a combo box in. Line edits. So this is pretty simple to play around. You just open a new user interface and just place some controls to it. So you see it's many widgets available. Okay, a tool button is just a tiny button which you can use in the toolbar on top of your application. So we'll see that. A splitter, does everybody know what a splitter is? You know this from, for instance, Explorer, where you can move the tree and the list view. So the way of implementing this is, just show it to you. So let's just take the Explorer example. We put a tree on the left side and a list on the right side. We just select both of them and arrange them in a horizontal splitter. Okay, so let me just set a layout on our form, and now we to show you, we could preview this. So by previewing it, we see that this is now a tree and an empty list gets resized, and in the middle we see the splitter. And that's pretty simple. Okay, a queue stacked widget is just a stack of widgets where you can bring one widget on top. So, like if you have a tab widget and you say page 3, this comes on top of all the other pages. So, going deeper into the layout management, let me explain you the following. Normally, if you want to do it yourself, you can just call the move, resize, or set geometry functions to define the bounding rectangle of your widgets. So it's completely up to you. Whenever you like to do that, you can do everything manually. Just, for instance, by resizing the widgets or moving it to the right position. But that can be very tedious work, especially for all languages, for all kind of fonts on different operating systems. You have to take care of that yourself, everything manually. So it's much better that you let Qt do the work for you. So, of course, the big advantage is that it handles everything automatically. It handles different languages, different dialog sizes, different resolutions. You never know what your client is using, which hardware, which screen resolution. And the usage of layout is much better to maintain. But when you deal with layouts, you have to think about your layouts first. So, of course, when we're letting Qt do the job, then we are not allowed to call the move, resize, or set geometry functions anymore. So instead of calling these functions, we have to tell the layout manager what to do and which widget can increase its size, or we can define the size hint. So the size hint is the preferred size for a widget. let's say this is the default size. And then you can call the set minimum, maximum size to set the boundaries. Let's say a widget should not be wider than 300 pixels. You can just set a minimum width to 300, a maximum width to 300. So this is the functions you have to call to influence the layout. And there's different layout managers available, like the horizontal and vertical box layout we already know. The grid layout is a table layout where you have different cells. You can also combine columns or rows, which is called a row span or a column span. So the form layout is some special case for a two-column input widget, where you have text labels on the left and input fields on the right. I will show you. And the stacked layout is a special case where you have one widget at the top. So only the topmost is visible. So again, here is another example on how to create H and VBox layouts. So that's the one we already had. So by just creating the right layout, in this case an HBox layout, we can add the widgets to it, 1, 2, 3, 4, 5, and we set the main layout of a widget to this horizontal box layout. And then everything is handled automatically. So the same applies to a grid layout. The only difference is that now we have columns and rows. And if we want to combine cells together, like this button 3, which goes over 2 columns, we can just define a column span to populate 2 cells. Let me just show this to you in Qt Designer. So let's remove all this. So we have 3 push buttons. And now I would like to arrange everything in a grid layout. I just right-click on the empty space of my widget and say Layout, and lay out everything in a grid. So by default, Qt arranges my controls. So now I would like the 3rd button to use a column span with 2 columns. So I just click on it and try to increase the size to the right. So now it's going over through 2 columns. So, and if we preview that again, so everything is arranged in a grid control. So this is all something we can do in a graphical way. We can do it in source code, of course, but we can also do it in Qt Designer and see immediately what we get. Here is an example of a form layout. So form layout is a 2-column layout mainly with some labels on the left side and some input fields on the right. And this has some special look and feel on a Mac, so that the left column is right aligned and the right column is left aligned. So Qt specifies how the layout will look on different operating systems, so that you get a native look and feel. Okay, so let's skip the lab. And declares some more terms in the layout management. Now we have to specify what do we do with the space which is left. So maybe the widget is wider than what we really need. We have to specify what to do with the empty space. And now we can try to set some stretch factors. And a stretch factor specifies how the widgets will stretch. So in this case, this is pretty simple. We have the first column with a stretch factor of 2. The rest of the 2 columns have stretch factor 1. So the sum of all will be 4. And that means the first column gets 50%, and the middle and the right column gets 25% of our total space. So with the stretch factor, you can influence on how to resize the different columns or rows. Then we can define the margins. The margin is the space around the content. So let's take an example with Qt Designer. When I now click on my widget and go to the Properties window, I will now see that this layout has some properties. So let's make it visible. So by default, the left margin is 9 pixels. So if I like to increase that, you see this space here gets increased. So that's the margins. Then we have some additional space between the elements. In this grid, for instance, we have a horizontal spacing of 6 pixels. So that is the space in between 2 buttons. I can also individually set this, let's say, to 30 to increase the gap between the buttons. So that's called the spacing. Let me show you one more thing. The stretch factor. Let's add a third button in the middle here. So it gets automatically arranged in the middle. And now we would like to define the stretch factor. And this is also something we can specify here. So we have 3 columns, and we say the first column gets 2 and the other get 1 parts of our total space. So when we preview that, this is twice the width of these columns. Yeah, more layout terms. A strut is, it limits one box dimension. You normally don't need that term, but you need the min, max, and fix size. So this is something quite important to set the boundaries of resizing. It's also available in your property editor. You have a maximum size, which is max int. And if you say, I would like to have a maximum width of 300 pixels. So let's see. You see, if we come to 300 pixels, it does not increase anymore. So 300 pixels is the maximum width of column 1. So how can we nest layouts? The simplest thing is to use that in Qt Designer. So let's create another row. And I just put a vertical layout into the cell of our grid. So now I have a vertical layout within a grid layout and can just throw in some push buttons in this vertical layout. I can even nest it more. I can put 2 radio buttons in here. So I have another horizontal layout in the vertical layout, which is in the grid layout. So that's how you can assemble your dialogues. Talking about size policies. So this is a really difficult chapter, and you have to understand how to set these flags correctly. So it's a big difference in how your widget can occupy the space. So maybe sometimes it doesn't make sense to increase in width because you don't have an advantage. A text label, for instance, if the text is shown completely, it's no benefit of getting bigger. So, and therefore you have a size policy in each direction, one in horizontal direction, one in vertical direction. And then you can tweak the behavior of your widget. And by default, if we take a look at the predefined widgets, we can take a look at the size policy. For instance, a push button has an horizontal policy minimum and a vertical policy fixed. And that means the vertical size is fixed. So in this case, the height of the button is 23 pixels, and that's it. It cannot grow or shrink. And I will let you know what this minimum means on the next slides. So therefore, you can set the size policy of each widget individually. By default, it gets the size hint size. So whenever you create it, this is the default or recommended size for a widget. So, and this is the table you have to take a look at whenever you want to have a different behavior for the size policy. This is the way of setting it correctly. That's also available in Qt Assistant. When you set the size policy to minimum, that means the size hint is the minimum size, but the widget can grow. So the maximum sizing policy of maximum means that the size policy is the maximum size, but the widget can shrink. So preferred is the size hint is best, but it can shrink or it can grow, but there is no advantage of growing. And then you have these expanding policies. Let's say if you have a text input. Let's do the following. So let's add a text edit here. And suddenly you saw that it expanded in the vertical size, taking all the space in vertical direction. So the text box likes to be as big as it can, occupying all the free space that the user can enter as much text as he wants. So by default, the size policy of a text box is set to expanding in both directions. Just meaning, like a spring, try to be as big as you can. So, let's try to do some exercise. In this lab, you normally do it on your own, but let's try to do it with Qt Designer. So we have different ways of layouting the 3 buttons. So let's try to prepare this. So throwing away all this, breaking the layout. So we have a group box and we have 3 push buttons in each group box. I give the group box a horizontal layout. Okay. So now we need 1, 2, 3, 4, 5 of these group boxes. And lay out everything in a vertical layout. So this is our starting point. And we can just preview that. And you see this is the behavior of the push buttons. So what do we have to do now? So the starting point is what we have right now. And now we would like to stretch by the factors 2, 1, 1. So we already showed this. I just click on the group box, and the group box has a layout property with a layout stretch where I just specify these stretch factors. And even in edit mode, I see the correct stretching factors. So that was simple. So exercise 2, find this stretch. So the first button should be as big as it can. Any idea what we can do? So there's 2 ways of doing that. So the first one is if I tell the button to get a size policy expanding. So it expands in horizontal direction as much as it can. Just take a look at the preview so you see it gets all the space. So another way of doing that is if I click on the size policy, you see this tiny reset button. If I press on that again, I can reset this property to default. And now I can specify a stretch. So if I specify a stretch 1, 0, 0, that means all the additional space left will be set to the first column. So column 1 gets 100% and the rest gets 0. So the next exercise here would be to add a stretch at the end. And here we have some additional elements within our toolbox, which is called a horizontal spacer, which is like a spring. And we can place the spacer on the right side. Missed it. Here you see. So I added the spacer at the right side. The spring tries to expand as much as it can. And running this in the preview, you see that this spacer gets all the empty space. And the last one is also pretty simple. Now we try to occupy the space in between the buttons. So same space here and in between here. How do we do that? Same. Just by adding 2 horizontal spacers in between the push buttons. So you see, this additional space is divided in the same portions here. Then with these kind of tricks, you can tweak your layout how you want it. And you have to think about what happens with different languages. Should the button get a bigger size? So by default, everything is handled correctly for the buttons because they have the right size policy and follow the sizing rules of Qt. So the size policy of a push button is set to minimum. So the size hint is the minimum size, but the button can grow in size. Okay. So next Q&A session is just some simple questions. How do you change the minimum size of a widget? Of course, you call the set minimum size function. Or you can just enter it in the Qt designer and set the minimum size correctly. Layout managers. We know some new layout managers. We have the horizontal vertical grid, we have the grid layout, and there is a form layout or a stacked layout. Specifying a stretch, we have just seen in Qt Designer, but of course you can do everything from source code. So the last question is an important one. When are you allowed to call resize and move on a widget? You're only allowed to call these functions when you're not using a layout manager. But when you call these functions yourself, you have to take care about layouting of your components. Okay. So what do you have to do if you want to create your own custom widgets? So the widgets in the toolbox is not what you want, and you would like to create some fancy widgets yourself. So you will define a new class custom widget which is derived from QWidget. So that means it inherits all the functionality from QWidget, and then you have to do some special implementations to your custom widget. Of course, the first thing you have to do is you have to specify a constructor, and you should follow the rules, what we already know. You have to specify a parent widget to your custom widget. Whenever you want to use functionality of the meta object system, you have to define QObject macro. And I strongly recommend you to do it as soon as you create your class, because you might definitely want to make use of signals and slots or properties. Therefore, you need to define the QObject macro. And then there is two different approaches. You can create some composed widgets. Let's say you would like to use some predefined widgets and create a new widget which has a label and a combo box, and create a new widget out of this. That's what you call composed widgets, and therefore you can use layout managers to arrange your elements correctly. Or you can paint the widget yourself. Let's say you have some graphical widget where you want to show some information, graphical information. Then you can override the paint event and draw the widget yourself. Just plain drawing function, draw a line from A to B, draw a circle, draw a text, everything within the paint event of your widget. So that's the two approaches you can go creating your custom widgets. So the first thing is what you should check, whether there is anything available which you can use. Do not reinvent the wheel. It's many widgets available in the internet or in the widget gallery, and you make use of it. Maybe it needs some different styling. But if you do not find something, then you have to decide about the base class. Do you derive from QWidget? You will have to re-implement everything yourself. Or can you derive from QFrame because your widget has a frame? So it's much better to derive from QFrame and make use of the functionality of a QFrame. So and once you decided about the base class, you have to think about the event handlers. How is the user interaction of your widget with the user? How can he interact with the mouse and keyboard? So that means you have to override the mouse press, mouse move, and mouse release events. And of course, you have to override the key press event for keyboard input. And then you have to think about focus. So what happens when a focus in event happens? So you might want to change the appearance of your widget when the widget gets the focus. So that's all something you have to think about. Okay, and again, in the guidelines, first of all, think about if you would like to implement a composite widget using some predefined widget and use a layout manager, or if you want to draw everything yourself. So when you paint everything yourself, you have to override the paint event. And this is the place where you draw your widget completely. So within the drawing, in the paint event, you have to think about internal states. Maybe your widget has a property selected or not selected, then you draw it in this way. If it's not selected, draw it in another way. Okay, once you have decided about the drawing, you have to decide about the signals to emit. You would like to make your widget as good so that someone else can reuse your widget. So, and then you have to think about what is important for an outside user of your widget. So maybe in the slider example, they thought about if the value changes, of course, I have to emit a value change signal. Or if a push button gets pressed, it has to emit a signal so that the button was pressed, of course. And normally you do this emitting of the signals within the event handlers of your widget. So let's say if the user clicks on your widget, you emit the click signal. if you think about parameters of your signals, so we had the question this morning, think about the parameter types. So if you're using basic data types, so it's more likely that someone can reuse your widget. Try to make it as easy as it can be so that someone else can make use of your component. So, and as for any other C++ class, you have to decide on publishing internal states. So what do you want to make public to the outside? And when you decide to make something public, it might be a good idea to implement this as slots so that someone can connect your widget function to a signal. So in the slider example, the setValue function is a very good candidate for a slot because someone else can connect a signal to your setValue slot. And if you decide about subclassing and you allow that someone derives from your widget, you have to think about which functions you will make protected instead of private. And of course, you have to think about virtual functions. So maybe sometimes it's good to have different kind of constructors available. And you see this also within the Qt framework, that sometimes you have different kind of constructors available. So think about different constructors to make the life easier for someone who wants to instantiate your components. So here is a good lab how to implement a composite widget. So this widget just consists of a line edit and a push button. And using, in this case, a horizontal layout to arrange the controls. So let's discuss the API a little bit. So we now take a look in the solution of this lab. Okay, the starting point of this lab is an empty widget. And now we would like to put some action in this widget. And let's try to open the solution. So now we have two projects within Qt Creator. So the highlighted one is the default. So in here we see the result. We have line edit. We have a push button, and whenever we press this button, we just get a file selection, which lets us select a file, and the file name will be set in the edit, in the line edit here. So how did we do that? So in the main function, we just instantiate the file chooser widget, and the file chooser widget is derived from QWidget. So it has a normal constructor, and it has some additional properties. So the first property is the mode, whether we select a file or a directory. And the second property is the file name. Of course, we need the getter and the setter methods, and we define the setter methods to be slots, so then that someone can connect a signal to it. Whenever the user selects a new file, we emit a file name changed signal. Might be very useful for someone else. And we have a private slot. Whenever the push button, the ... button is pressed, we can choose a new file. So let's take a look at the choose file. Therefore, I click on this and I say follow symbol under cursor. So we automatically go to the definition of this function, and we see, depending on the mode, we show a get file open name, get open file name, or a get existing directory. So once the user has selected a new file name, we just set it in the line edit, set text, and we emit a file name changed signal. So the private members we have in this class is the line edit, the push button, and the current selection mode. So any questions to this API? Something missing? No questions?
Question regarding the layouts and the automatic resize of the buttons. That was very impressive. But I was wondering what happens if there are labels and the labels contain bitmaps. Will these bitmaps somehow be resized, even smoothed up, or will they just remain as small as they are?
So we don't have a UI file here.
Yeah, I'm asking because Adobe Flash, for example, can do this.
So let's put a label to this dialog, and just selecting oh no, I don't see the input dialog. Where is it? I think this input dialog now is shown on my second screen. But you see, there is a scale contents property which you can enable so that your pixmap gets scaled. If you do not select this, it will have a fixed size. Is it okay? Yeah, but now let me try to get this. Okay. Alt-tab? No. No, there is some. If you press Alt and then how do you move that? No. Okay, never mind. I think I just press Escape to get out of it. But normally you see this file input dialog to enter a pixmap file. Okay, so we'll.
Sorry.
Yeah.
Then I have the next question.
Yeah, go ahead.
My question going to the same area. So I have seen here on my colleague that he is moving this picture bigger and smaller.
Yeah.
But my question now is, if I see it, if it's a pixel, it's in a special size and it's going up bigger, then it's looks different or not so nice. Let me see.
Yeah.
So the question is, can I use a bigger picture than in it? Automatically will be minimize?
If you have a pixmap and you scale the content, you will always get this kind of artifacts. And so it's always better to have a large pixmap and to scale it down.
That's my question.
Yeah.
I can use a larger one, then it's normally
Yes.
automatically going to a small picture.
Yes, you can do that. And Qt also has some functionality where you can increase the rendering quality for pixmap transformations. So whenever you try to paint pixmaps yourself, you can set some rendering hints. And here you can enable a smooth pixmap transformation which tries to increase the quality of your scaled pixmaps. But of course this needs some extra calculations, so your application might get a little bit slower, especially on embedded platforms. Okay, so let's skip the next lab and go to the module application creation. So now we would like to make a regular application which has a main window, maybe a menu and a toolbar, so that it looks like a native application. So in this chapter, we will see how we can make use of the typical main window elements. Yeah, as I said, like menus, toolbars, status bars. We can make use of docking widgets. And then we think about application settings. how can we store some application data? And you already said something about pixmaps. Normally, we don't want to deploy the pixmaps. So we'd like to add the pixmaps to the resources. How can we do that? If we have a main application, we also think about translation for multi-language support. And the last one, of course, we have to think about the deployment. How do we get our application on the target system? So a typical application looks like this. You have a window decoration with a caption bar, some close buttons, menus, toolbars. We have a status bar at the bottom with a size gripper here, and then we have some content. Okay, so let's try to create an application like this. So coming back to our Qt creator, so let's try to create another GUI application as we did this morning. And now we derive our main window from QMain window, inheriting all the functionality of a QMain window. So and when we run this template, we get an empty application with a window with a close button. We have an empty toolbar here, which already supports docking functionality. And we have a status bar on the bottom with an additional size gripper to resize our main window. Okay, so let's try to bring some life into this application. And we would like to add some actions to it. So an action is an abstract user interface command like file open. You would like that the user can open a file. So therefore, we can set up some actions. On this slide, we see the source code you can use to set up your actions, or we can do it in Qt Creator directly. So as you see here, the wizard already created a main window.i, so with an empty main window. And now we have an additional action editor on bottom where we can specify new actions. So if I add a new action, I can specify a text. So that's the default name. I can specify a tooltip. I could specify some additional icons. Can tell if this is a checkable action or not. And I can also create a shortcut. So let's press Ctrl-O for opening. So now I have an action here. let's try to add this action to our main menu. So normally we have a file menu, and underneath this file menu we would like to add the file open action. So I just drag and drop it in the menu here, and you already see the file open. But normally this is not the only way to open the file. We would also like to add this action to our main toolbar. So I drop this action again on the toolbar, so I get the same action added here again. So let's try to run this. So you see I have a menu with an open menu item and an open tool button in our toolbar, which doesn't do anything right now. But the important thing to remember is we only have one action, and we can instantiate this action in many places. Maybe later on we have an additional context menu. If the user right-clicks somewhere and we would like to add this action to the context menu, we can also make use of the same action. Of course, we can enable or disable the action. We can make it checkable or not. And we can attach some additional data to it. So everything what fits in a quivariant can be attached to an action. Okay, here is the source code to create menu bars from within the source code. It's the same what we did with Qt Designer. And how to set up the toolbars. So what we can also do is, let's just create a new, or close, and okay, let's add a close and an exit. And I would like to add a separator. I just click on the separator and move it here. And the same we do for the toolbar. So and once you specify a pix map for these actions, you can also say show the pix map instead of the text, which is the default behavior of a tool button. Okay. Yeah, here is some additional functionality on how to interact with tool buttons, how to set it up from source code. But when we use Creator, everything is done for us. The status bar is already there, and here is the API functions, how to display some messages within the status bar. There is a show message function. You can just give it a message and a timeout function. So if you specify 3000 milliseconds, it will disappear after 3 seconds. So then the Q main window automatically supports docking widgets. So whenever you try or you want to have docking support, use the Q dock widget and define the areas where you would like to enable docking. So you can individually set it, all the 4 positions to allow docking or not. So if you want to create your custom context menus, this is pretty simple. You can just make use of QMenu and just call the exec function of the QMenu and give it the right screen position. So whenever, let's say, the user right-clicks somewhere on the screen, you can create a context menu at this screen position. So again, here is a summary of important API functions. So that's what we had on the previous slides. Functions to create main windows, to create actions, handle toolbars, menu bars, and status bars. That's the typical APIs. So now let's try to implement our own text editor. So we have nearly 10 minutes left before the break. You think that's enough time? So let's give it a try. The good thing about the text editor is that we can make use of a QPlain text edit, which we will add to our main window. So we lay out everything, and in this case it doesn't really matter because it occupies all the space. And now we would like to put some text in the text widget, and the user should be able to select a file. So we have an action to open a file, and if I just right-click this action and I say go to slot, I get a list of signals, and the triggered signal is the default. And if I say OK, I get a predefined slot, which is called when this action gets triggered. So now we would like to open a file open dialog. So get open file name wants a parent, which is the main window itself. It likes to have a caption. So just give it it normally gets a default directory, but that's something we can skip here. So now let's try to run this. So what will happen if I press the open button? I get a file open dialog to select a file. Yeah, so, and this file, let's set a breakpoint. That was too late. Okay, normally you get into this breakpoint and you will return the file name of your selected file. So now we would like to read the content of the file. So we create a file based on the file name, and we like to open the file in read-only mode. Normally we should get the return value and look if it succeeds or not and do some error handling if it fails. But if everything goes well, we read everything into a text stream. And we try to set the whole content of our file to our plain text editor. So let's try to access the plain text edit. So with UI, pointer plain text edit, and then try to set the plain text maybe some includes are missing. Yeah, Q text stream. Okay, our text editor is finished within 3 minutes. We still have 6 minutes left. So you see how simple it can be using pre-defined components, because the main work is done in the QPlain text edit. It does all this text rendering, and the user can see all the text in the file. Okay, any questions?
Probably a general question. So the application we build now, it's an application for the PC, right?
Yes.
We have the development environment for the PC. What are the steps to be done to have that application running on a Nokia phone or any other phone then?
Okay. So first of all, you have to install the SDK for Nokia mobile phones so that you can target Symbian platforms. And then it's more or less the same. You have the same source code. There is some things you have to keep in mind because the mobile phones are restricted in the display size. You might want to show your application in maximized mode. So let me take a look if this is... Normally, you get in your main function an ifdef running on Symbian or an embedded target. You show your application in maximized. And then you can just target any kind of device, and you will see these targets here in your target selection. And if you have the Nokia SDK installed, you will see a target for your Symbian device. And once you connect it to your PC, you can select your mobile device to be the target, and then everything is packed in an SES package and deployed to your mobile phone. More questions? Okay, so let's take a break.